Okay, this is section 1.3 in Book L. It's on controlling chemical reactions and how we just talked about what a chemical reaction was, how to balance a chemical reaction, and now we're going to talk about how do we make it happen, or what causes it to start, what causes it to stop, how can we control them if we'd like to. I know the book kind of starts off talking about how demolition works, how maybe we want to take down a building, but we don't want to take down anything else around it. So for instance, a couple years ago, maybe 3 years by now, they took down a residence hall on UNL's campus, but they didn't want to take down everything around the residence hall, so maybe just the residence hall, but not any other buildings around. They didn't want that to be affected. So they kind of blew it up, basically. They put some explosives in it that made it come just straight down. People that work in that have to understand chemical reactions because they want to just keep it in one area. They want to control that so it doesn't make everything in the whole block blow up. And so that's what they had done. They used something like that to help control it. So chemical reaction is a change in energy. So it's either released or absorbed. We talked about this before, exothermic and endothermic. If it's exothermic, it releases energy. If it's endothermic, it absorbs energy. So if something heats up when it goes through a chemical reaction, we call it exothermic, or you can feel that heat coming off of it. If it's endothermic, it cools down. So for instance, if you ever use one of those like ice packs that you have, like maybe you break it apart and then all of a sudden it kind of starts to cool down. So you can use that ice pack without actually having ice in it. That is an endothermic type chemical reaction. So there's chemicals in that ice pack that when you break it apart, the reaction creates a cool down. So it causes energy to be absorbed or cooled down. And so right down here, we're going to talk about this in the next one. It's called activation energy, which is what things caused. So there's a difference between endothermic and exothermic. So this is the energy that we have for our reactants, and then they start kind of coming together and they start to build. The energy builds until we get to the point where the chemical reaction starts. Okay, so we're putting things together and the energy starts going up till we get to the point where we have what we call activation energy. It's the energy that basically gets the chemical reaction started. And then once that gets started, the energy starts to go down. If heat is released, that's what we call exothermic. That means that it's going to just keep going down, and in the meantime, as this energy kind of is going out here, we see that heat released, and that's what we call exothermic. Endothermic, same basic idea, we're building energy, and then we get to the point where we have activation energy, and we start to go down, but heat is absorbed. So you don't see it go down below this line of energy to begin with, so it cools down instead of heating up. Okay, so it's activation energy, what gets it started. Okay, so this is what I was talking about on the last slide, activation energy. This is the minimum amount of energy needed to get a chemical reaction started. So they're just basically showing this comic here, this like picture that's been drawn, or the model here is this goat pushing this rock. He wants to get it over the cliff there. So he looks at the rock, oh, there it is. Okay, well, I need to provide some sort of energy to get it over the cliff. And so that's what he's doing in the second picture. So he's looking at it here. Okay, what do I need to do? Oh, I need to provide some energy. And look at that. Once I get it to the cliff, I pushed it enough, oh, it falls down on its own. So that's what activation energy is we put a little bit of energy into it, and then once it gets to the point where it's got all the energy it needs, it takes off and it does the chemical reaction. So this is to get a chemical reaction started, we need what we call activation energy. If you were going to create water needs a spark to happen. So you don't just take hydrogen gas and oxygen gas and put them together and you get water. That's not how it works. You have to provide activation energy. You have to provide a spark for that to happen. Otherwise, just putting those gases together isn't enough. You have to provide something for that in order for water to be created. Okay, so rates of chemical reactions. We want to be able to control these things. So the factors that affect those rates are concentrations, the amount of material there, the surface area, what's exposed, and of course the temperature, how hot or cold it is. So concentration affects the chemical reaction because the more material, the more particles available to react. So concentration here, so the bubbles of hydrogen gas and the magnesium reacts with acid. So if there's more magnesium in here or more acid, we're going to have more particles to react with each other, which creates a bigger reaction. So there's more particles in here, more concentration here than there is here. You can see a bigger reaction taking place. So more equals bigger chemical reaction. So if I add more to something, I'm going to get a bigger or more complex chemical reaction because there's more particles to react. Here's surface area. This is showing surface area. This is the grain dust explosion. Basically what happens in a grain dust explosion is we need less dust in there because the more there is, the more particles there are, so there's more surface area. Because they're dust particles, there's more of them. There's more surface area for each dust particle to be part of that reaction. So because there's more material exposed, the quicker the reaction will happen, which is why you have explosions in dust grains, or in grain bins, because sometimes there's too much dust. So you need to minimize that because you don't want explosion in grain bins. But surface area, basically, the more area that's exposed to be reacted, the quicker the reaction will go. So the last one is rates of chemical reaction. So increasing heat will add activation energy, which means it'll increase the speed of particles, which again will cause the chemical reaction to speed up. You can also put what we call a catalyst in there. A catalyst is something that increases the rate of reaction because it lowers the activation energy. So you can put something into the reaction that causes that activation energy to go down. You won't need as much by providing a catalyst. An enzyme is a type of catalyst. So right here we're showing an enzyme. We've talked about enzymes before when we talked about digestion and things like that. But enzymes are found naturally, usually, and those things can be used to take and create a reaction. So a biological catalyst is an enzyme which causes a reaction basically to take place, but the enzyme is unchanged, which means it can be used again and again and again. But it helps kind of speed up that chemical reaction. And an inhibitor will decrease the rate of a chemical reaction. Sometimes just cooling something down will release that chemical, or release the rate, or decrease. So as I was saying, inhibitors decrease the rate of chemical reaction. Food is a really good way of, when chemical reactions happen in food, that's when food starts to spoil. A lot of times you'll put food in the refrigerator to keep that spoilage from happening. So the refrigerator becomes an inhibitor. It decreases the rate of that chemical reaction that can cause spoilage in your food. Alright, so this is that second section, or section 3, I should say, in chapter 1. There is a worksheet that goes with this that you can either print off, or if it's in the packet that came home, and or you can do it on a separate piece of paper, take a picture and send it in. Any way, you can always take a picture of it, send it back to me, or scan it some way and send it back, or whatever works best for you. You can either send it via email, or you can upload it on PowerSchool Learning in the messages area, and just send it to me that way. I'll get it that way too. Alright, enjoy!